Here is a very interesting question. It is asked in communication and thinking problems. The question is, will rational function always have a discontinuity? A discontinuity type normally you've seen. A rational function has a vertical asymptote or a hole, right? I hope you remember what a rational function is. Let me define that first. So rational function r of x is defined like ratio of two polynomials, right? P of x over q of x, where q of x is not equal to 0. On this q of x, when it is 0, it leads to restrictions, or I can say vertical asymptotes or holes, right? So I have other videos on vertical asymptotes and holes which you can look into to understand these two things clearly. So the question here is, will all the rational functions have a discontinuity like vertical asymptotes or holes? That's what we are going to look into. Okay. Now, because students think yes it will, and that is how they give difference between rational functions and other functions. Normally their answer is that rational functions have asymptotes and holes, the other functions don't have. They are right in a way, but they are not absolutely correct. All rational functions do not have holes and or vertical asymptotes. Like I will show you here with an example written just here. Nx equals to 1 over x squared plus 1. Try to sketch this function and see for yourself whether it has a hole or a vertical asymptote or nothing. Now, this you can see is reciprocal of a quadratic function x squared plus 1. So, let's sketch x squared plus 1. That will make things very simple. X squared plus 1. X squared is a graph like this, right, which goes through origin. Plus 1 is translated 1 unit up, for example. And this is my x squared plus 1, right? So that becomes x squared plus 1, where this is 1. So I'll write this as f of x equals to x squared plus 1. Now as you can see, there are no x-intercepts, right? This function is always greater than or equal to 1, always positive, right? Now for this function, can you draw reciprocal of this function? That means 1 over x squared plus 1. Can you draw that? Well, that is interesting. You will see reciprocal of 1 is 1, so that will be a point. And as we move here, these points will become lesser than this. All these points are becoming more and more than 1. So as we go further and further, we are approaching infinity. Reciprocal of infinity will be 0, so we will be approaching infinity. As we approach infinity for the quadratic function x squared plus 1, the reciprocal will approach 0, right? And 0 from positive side, because it is always positive. You also know that reciprocal of positive numbers is positive. So the whole graph all along the domain of real numbers will be positive. We will never have a negative value. So it will never cross the x-axis, right? So if you sketch it, you will get a function like this. Do you see that? Now this function is your nx, 1 over x squared plus 1. As you can see, it does not have any discontinuity. So there is no question of any vertical asymptotes or holes, right? In general, if the denominator is not 0, then we will not have discontinuity, correct? So you check for that. So if you equate x squared plus 1 equals to 0 and try to solve this, you get what? You get x squared equals to minus 1 and x equals to plus or minus square root of minus 1. Not rational, right? So we don't have any real discontinuity here, right? So we don't have any vertical asymptote or a hole in such a case. Therefore, we can now say that there are many rational functions which will not have vertical asymptotes or holes, right? That is, there are many rational functions which will be continuous all along their domain of real numbers. Okay? That I hope you remember this diagram and this example. And don't make a mistake this time of saying that rational functions are those. Say rational functions are those which can have vertical asymptotes or holes. The other functions or polynomials cannot have vertical asymptotes or holes. That is a better distinction. Okay? Thank you.